Hey everyone, what's up and welcome back to our Utsource channel. In today's video, I'm gonna show you guys how you can use this BC847 NPN occipital silicon transistor in your projects to control all kind of loads. In my case, some SMD LEDs with a PWM signal generated by a microcontroller. In my previous video, I did the same thing with the AO3400 N-channel MOSFET. This BC847 package and size are also similar, but only difference between these two is the type. This is a MOSFET and this is a transistor. As you might already know, transistors are used for low current applications, where the MOSFET is used for high power applications. Also, the structure of MOSFET is more complex than the BJT. But the main question here is where we can buy this from. You could buy this transistor from utsource.net. Link is in video description. BC847 is an NPN transistor that is available generally in the SOT23 package. Following are its electrical parameters. Collector base voltage is around 50 volt. Collector emitter voltage is around 45 volt. Emitter base voltage is around 6 volt. Collector current is around 100 mA, which is quite low, so you can only power loads whose current is smaller than the 100 mA. For example, few LEDs and stuff. The power dissipation of this transistor is around 310 mW. You could check out more details from this transistor's datasheet, which can be downloaded from our Utsource page. As for its working schematic, I use this configuration which consists of 3 LEDs connected in parallel with the transistor. A load resistance is between them to limit the current a little bit. Then there's a 10K resistance on the base, and between base and emitter to ground the transistor's gate whenever the PWM signal is not being sent to the gate. This schematic can be easily made on a perf board, but I didn't want to do excess work of soldering stuff together in a makeshift setup. So instead, I used the classic PCB etching process for this project. Here's how I did the etching process. We start first by making a board in the PCBCAD software. Then we export the bottom layer PDF file so we could print it on a glossy paper. Then we transfer the ink from the glossy paper to the PCB board by providing it heat from the top side. Then we etch the whole board with the ferric chloride solution, and this will be the result. Before starting the assembly process, I gather all the components required for this small build. Custom PCB, BC847 transistor, 1 ohms resistance, 10 kilo ohm resistance, few SMD 0603 LEDs and header pin. After the assembly process, the end result will be this small LED board which is driven by the BC847 transistor. To drive this LED module, we require a microcontroller which would be an Arduino Nano board in my case. Wire everything together with this schematic. After wiring, we upload a general fade sketch to our board and then power it up with any power source, which in my case is a power bank. PWM fading is working nicely in this setup, which was the goal of this build, to use a BC847 transistor to control a load, LEDs in this case. And this is how you could use a BC847 transistor to drive LEDs with a PWM signal generated by a microcontroller. Leave a like if this video was helpful, or maybe subscribe. And I'll be back with another video soon. Peace out.